Welcome to the natural base e. Today's objectives are to use the number e to write and graph exponential functions. And then we want to learn to solve equations and problems involving e or natural logarithms. Now we want to use the compound interest formula to develop the number e. So if you remember that the compound interest formula started off to solve for some final amount, we had to take a principal amount and multiply it by 1 plus the rate divided by how many times it compounded continuously. So we knew that P stood for the principal, N stood for how often the amount was compounded, and T stood for time. So now, let's say I invested $1 over 1 year and it compounded n times. So I'll leave this as my variable. So that would make my equation equal 1 plus 1 divided by n raised to the n. And t is just 1 because it's 1 year. So now we want to look at this equation and examine what happens as n gets bigger. Let's start with a small number. So let's say that n equals 1. So if n equals 1, this function here becomes 1 plus 1 over 1, which is just 1, raised to the 1. So 1 plus 1 is 2, so this answer is 2. How about if n is 10? If n is 10, we have 1 plus 1 divided by 10 raised to 10. And this comes out to be about 2.59. Now, if these numbers keep going up, up, and up, what we're going to notice is these numbers start to get closer to this number. .71828, and it repeats. Now this number right here is known as the number e, and it's an irrational number. So what we want to know is that this number e comes from this function. Now when you're graphing these functions, you want to make a table of values. And I'd recommend picking at least 1 or 2 easy values for x and then doing the rest in your calculator. So I'd start with 0, because anything raised to 0 is just 1. So if e is raised to 0, that's 1. 1 plus 2 is 3. I'd plug 1 in, and then I would do that math out of my calculator, and I would get 4.7. If x was 2, I would get 9.4. And let me get one negative value. If x was negative 1, y would be 2.4. So let's graph these now. So when x equals negative 1, I have 2.4. When x equals 0, I have 3. When x equals 1, I have 4.7. And when x equals 2, I have 9.4. So we can see is a curve, and it starts to bottom out around y equals 2. So we studied the inverse functions between exponential functions and log functions. So we want to introduce now what the inverse function of e to the x is. So if we were going to write this in logarithmic form, it'd be log base e of x. But this isn't how we write the log forms of e to the x. Whenever we see log e to the x, what we really want to start thinking about is it's written as ln of x. And this is called the natural log. So this is called ln of x, and we call that the natural log, which is just the inverse of e to the x. Now, when we're looking at the domain and range of e to the x, look at our graph here, we see that the domain is going to equal all real numbers, and the range is going to equal all values of y that are greater than 0. So since e to the x and ln of x are inverse functions, if I want to find the domain and range of ln of x, all I have to do is do the inverse. So I got to swap them. So now the domain is going to be all x values that are greater than 0, and the range is going to be all real numbers. And we can see here in this graph that the x values don't go lower than x equals 0, and the range is all possible y values. Now you can use that knowledge of how the ln function is written to help you simplify some logarithmic expressions with e in it. So think about, for this first one, that whenever you see ln of some variable quantity x, what it really means is log e of x. So for this first problem, we have ln of e raised to negative 2t. We can think about this as log base e of e raised to negative 2t. Now we know because of the inverse property, whenever these two are the same, they cancel each other out, and all we're left with is negative 2t. For part B, we have e raised to the ln t. Once again, remember that ln is just log base e, and we now have a quantity of t minus 1. Now once again, the inverse property tells us if these two terms are the same, these get canceled out, and we're left with t minus 1. Now for this last one, we have e raised to 5 ln of x, but since I have that 5 up there, I want to use the product property to put it up top. So I'm going to have e raised to the ln x to the 5th, take that and put it up here, and then I know that since it's ln, it really is log e, so what I'm left with is x to the 5th. Let's do a few practice problems. So for the first one, we have ln of e raised to 3.2, so that's just going to be 3.2. For the next one, we're going to change this to e raised to the ln of x squared. That's going to cancel out, we're left with x squared. And for this last one, don't get fooled by the x and the y, it's still log base e of e raised to the x plus 4y, so we're left with x plus 4y. Now the equation for continuously compounding interest is as follows. So you have the amount equals the principal amount times e raised to the RT. So R stands for rate, T stands for time, and P is the principal. So let's say we had a total amount of 1,000 invested. It was invested at 5% for 10 years, and it was compounding continuously. We want to know what's the total amount. Now, to figure this out, since we have our equation here, we would just plug these values in. So we have the amount's going to equal the principal of 1,000 times E. The rate is 0.05 times 10. We punch this on our calculator, and we get about $1,648.72. Another equation that uses the irrational number E is the half-life of a substance. Now this equation is written as follows. So NT is the amount remaining. NO stands for the initial amount. E is E. K is the decay constant. And T is time. So we have NO is the initial amount. K is the decay constant. And T is time. So the half-life of a substance is the time it takes for half of the substance to break down or convert to another substance during the process of decay. And we can figure that out using this formula. Which, if you notice, is very similar to the previous equation that we did. So the difference is that our rate is now negative. And that's going to be the end of the video for today. This was Natural Base E, and I hope it was helpful. Thank you. Take care.